Hi everyone. Today we're learning how to solve systems with three variables, and therefore there would be three equations. And the first system is set up so nicely because it's set up to use back substitution. Have you ever heard of back substitution? Maybe we've just never called it that, but I bet. Right. So we already know if we were to write as x comma y comma z as an ordered triple, we already know that was supposed to be a 2. We already know that our z value is 2. You see that? All right. Now if you go back and substitute that back up into the second equation, what would y have to be? All right. So now we know z and y, and so then we can go back and plug those up in here. 10, 2, so we'd have 2x plus 10 minus 6 equals 10. Did I mess that up? I think that's right. All right, that's called back substitution. Are you kind of hoping that all of the systems are set up to look just like that? Me too. The thing that makes this so easy is that, do you see this sort of blank area right here? Because there was no xe, ye stuff in there, it was easy to use back substitution. I call this the triangle of opportunity. Because if you have a nice blank triangle right here, then you'll just be able to back substitute. Any questions? But Mrs. Backlund, what if there is no triangle of opportunity?
You ever listen to yourself talking?
Yeah, it's painful. Yeah. Did you notice this example does not have a very opportune triangle because it's not cleared out in there, and so back substitution will not go as well. So there's a fancy name for triangle of opportunity. They call it row echelon form. So that's our goal, is to clear. Yeah, we're going to clear out that corner so that it's easy to back substitute. We are going to use Gaussian elimination. Now we are following in the footsteps of Friedrich Gauss of mathematics fame, okay? And we are going to follow his protocol. And not everybody is going to like it, and some of you might want to do your own thing, and to that I say no. We will do it as Gauss would do it. All right? Here's what Gauss says is a legal move. If I move these equations around and put this one last and that one second and this one first, that would be the same system of equations, wouldn't it? Yeah. And if I multiplied both sides of one of those equations by 3, it would still have the same solutions. And I know that I can do like regular old elimination where you can add two equations together and that's how you get the correct solution. So we're going to use those moves to make a triangle of opportunity, Gauss style. So I'll show you the first couple steps. My thought is I need to ditch this x. I'm also going to need to ditch that 3y, but I'm going to work one at a time. If I wanted to make that x disappear so that I'd have a nice blank triangle down in the corner, what would you do? Sure, you could use the top equation and the second equation and do some like elimination method. So we're just going to kind of write out our steps. I'm going to call this top one row 1. This one is going to be row 2, and this one's going to be row 3. And so what was your suggestion just now? You wanted to multiply which one by -1? The r. Oh, my call. I get to decide? Okay, well, maybe I'll go -1 times the second row, and then I'll add that to row 1. Do you think that would be a good move to get the x to disappear? Let's see how that looks. So I'm going to take regular old row 1, but then row 2 I'm going to multiply by -1. Negative, positive, negative, negative. And then what do you think I'm going to do with those? Add them together. No x's, 3y's, minus 3z's, -2. Have I messed anything up yet? Okay, here's where it's a little mind-blowing, because I think you've done stuff like that before. What I'm going to do is I'm going to rewrite this whole system again, only I'm going to replace row 2 with this little guy, the one where the x is missing. So I'm just going to rewrite the whole system over again. Row 1 is the same. Row 2 gets replaced. And row 3 stays the same. And what have I accomplished? I am closer to a triangle of opportunity because I got rid of the x.
Oh, so now you add bottom to.
How did you decide, which row you switch out?
Well, I knew that I wanted to have a 0 right here. So once I got rid of that x, I decided to put it in row 2. So that technically would be okay, but not if we're going to follow Gauss's pattern. Yep. Sam.
So does it have to be in the order R1, R2, R3, or can
You can switch the equations around. Yep.
so you could, in theory, have done top one, just switched it?
Yeah. Yep.
So like in the bottom, if it's like Z and X on the bottom, would you want to get rid of Y? Like, do you want to
Are you working on the homework at this moment? Because I'll help you with a homework problem. Let me get through one example first, though. Okay? I'm going to target that 3y and make it go away because I need to clear out this bottom triangle, right? If I wanted to get rid of that 3y, what would your method be? Yeah, maybe we could multiply one of those by -1, add them together. Your call, which one we do? So -1, maybe we could just change it up. We'll -1 the R2 and add it to the R3. It doesn't really matter as long as that 3y goes away. So I'm negifying the second row.
I don't like that.
And then I'm going to add it to the third row. And what do we get? No y's, 7 z's, and a 7. Where should I stick that? Row 3. Yeah. What? So I'm just copying down what I had up there, but then instead of row 3, I'm going to put the 7z equals 7. What do we have? A triangle of opportunity. Yes, Alex. Of course. Now that we have a triangle of opportunity, let's back substitute and see if we can find x, the y, the z. Does anybody think they know what z is? Did you say 1? Good. See, 7 times z equals 7. So 7 times 1 equals 7. And then if we back substitute that little 1 in there, 3 times y minus 3 equals -2. 1/3. I think I'm getting 1/3. Awkward, not the worst thing I've ever seen. Okay, now in the top equation, I've got x plus 1/3 plus 1 equals 3. What can you add to a 1/3 and a 1 to make a 3? A 1 and 2/3. There she is! Our solution.
Is that all we're doing today?
That's all we're doing. Yeah. It's not that bad. I'm glad. Andrew.
So what if, like the last one?
I would just target that x. You got to get the x out of there, right?
How so?
Well, we could do a homework problem after we do one more of my problems. How's that? Okay. All right. I have 5 minutes to do this problem. Do you think I can do it?
Yes.
Now that we know what we're doing, I think we could. We need to clear out that triangle. Do you think I should get rid of the x, or the y first?
Yes.
The only wrong answer was the y. So if you said the x, good. So you could get rid of either x to start out. Okay, if you started with the y, it wouldn't be wrong. It would just take you more steps. So start with an x. Any bright ideas? By the way, have you thought about this? There's actually more than one way to do this. We could either get rid of that x using the 2x from up or the 1x from down, and both would be correct. Your choice. Okay, so we're gonna... Okay, so you want to multiply the second row by -2? I'm still not opposed to that, so let's do that. So we'll have 2x plus 4y plus z equals 1. Negative 2x plus 4y plus 6z equals -4. And we'll add those together. 8y, 7z, -3. Does that look right? Okay. Where am I going to put it? It doesn't matter where I put it, but my goal was to get that x out of there. All right, I'm a third of the way there. Do I want to get rid of the x or the y next? You have to go x. Otherwise, you're going to add more steps to your process. How could I get rid of that x? We could -2 this row and add it to the top row. Okay. Say that again. You could always half the top row if you're into that.
Yeah, that's adding one to a fraction.
True. Do you think there's any chance you'll make it through one of these problems without it making a mistake?
Yeah, no.
Because I rarely do. So just be ready for that, and I'd be happy to help you find your errors. All right, assuming I haven't messed anything up. Is it in row echelon form?
Yes.
Not yet. We're just one step away. We just need that 2y to go away. Oh, well. You know what's actually super smart? If you don't use the top row this time. I'm glad you asked. Why would you not want to use the top row? It's going to get you more xy stuff back if you try to combine it. You don't want to mess up. You just got that. You don't want to mess that up. So instead, why don't we use row 2 and row 3? You with me? So maybe -4 this row. Does it equal 1 again? No. Oh, I'm not supposed to keep going. All right, and so I think I'm ready to write my final system. You could, yeah. Do you wanna? All right, let's simplify it down. Because we are allowed to multiply both sides of the equation by anything we want. So what do you want to multiply by? -1/5 it is. All right, so so yeah, that would be okay too. What form is this system in? Good. Row echelon form, also known as the triangle of opportunity. I'm the only one that calls it that, by the way. I should. TM. And then we could back substitute, yes? Yeah. You got me? 3 or -3? -3? Okay. And then 5?